Hello everybody. So for those who find my video without going through my website, let me introduce myself. My name is Gilles Ortubise, and my name as a self-taught and multidisciplinary scientist and inventor is Gilles Ortubise, and I am the owner and the founder of the first human multi-intelligence.com. So the title of this video is how our galaxy, the Milky Way, was born and how it has evolved so far, part 2. So, and this is a part of continued from part 1. So this is the part that's followed the part 1 before. So I just go right away to the text, which is the black hole 4 of 4. So I read the text and I add some more explanation when it's necessary to do. So right from a paragraph which start with, on the other hand, suppose that the current mass of the supermassive black celestial sphere at the center of our galaxy is 580 billion solar masses, and that it is the same as that of the rest of the objects that make up the Milky Way. Is it possible? Maybe so, if the gravitational forces of the supermassive black celestial sphere are strong enough to allow it to carry with it all the objects that make up the Milky Way, including its 56 satellite galaxies. And in relation to the gravitational engine of the solar system, which is our Sun, and which is capable of carrying with it all the objects which make up the solar system. So even though its total mass is about 99.86 of the total mass of the solar system, and taking into account that the gravitational forces of the Sun are proportionally much less powerful than those of the supermassive black celestial sphere at the center of the Milky Way. Regarding the evolution of our galaxy, the Milky Way, following its birth from part 1, the probable mass of the most massive and powerful supermassive black celestial sphere in the Milky Way at the time of its birth, which occur at the same time than that of our galaxy, it is likely to be in proportion to the total mass of our Milky Galaxy, which is equivalent to the rest of the Milky Way object, which must be 580 billion masses. So, and which is the same than the mass of the supermassive on the black celestial sphere in the center of the galaxy, for a total of 1,160 billion solar masses for the entire mass of the Milky Way. And in accordance with the text excerpt from the article Black Hole 404, which are actually black celestial spheres of all sizes which vary between dwarf and giants, and the modified text of September 30 this year, 2022, which are published on my website, which is firsthumanmultiintelligence.com, and in addition, additional argument in the following. So the paragraph from that article is number, start by this number, is 17.22.1.2 so I repeat again, 17.22.1.2 point. By hypothesis and in comparison, the mass of the gravitational engine of the solar system, which is the Sun, and it is 99.86 of the total mass of its solar system. So what I write on my website at that time, when I made the publication, I was making a mistake. So I don't want to read this mistake again because it's losing time, but I prefer to read the parts that I published on September 30, which is if the mass of its gravitational motor of the sphere supermassive black celestial is 4.5 million solar mass compared to the total mass of 580 billion solar masses of the Milky Way. Its gravitational motor has a mass that is only 0.000775% for its supermassive black celestial sphere, which must involve in its movement all the objects of the Milky Way, which is the second largest galaxy in the local group. On the other hand, suppose that the mass of the supermassive black celestial sphere from the center of the galaxy is equivalent to that of the Milky Way, which is 580 billion masses. In this context, the total mass of our galaxy, the Milky Way, would be 1,160 billion masses solar. Is this total mass possible? The answer to this question is positive. I believe it's about it, at least. So the next paragraph, moreover, in a context where the gravitational engine or the supermassive black celestial sphere of the center of our Milky Way, which is the second largest galaxy of the local group behind the Andromeda galaxy, which is the biggest one, which extends its gravitational power over the diameter of its disk, which is most often estimated between 100,000 and 120,000 light years. In addition, that other scientists indicate that its diameter can reach 200,000 light years, even if the number of the star beyond 120,000 light years is very small, and that its thickness is on average 1,000 light years. In this context, which of the two masses is more credible for the gravitational engine of the supermassive black celestial sphere at the center of the Milky Way? It seems obvious that the mass of only 4.5 million solar mass is insufficient and even at the antipode of all possible logic. On the other hand, the mass of 580 billion masses does not seem to be at the antipode of all possible logic, because what seems to be obvious is that this mass is possible considering the fact that it takes either a gravitational engine or a considerable powerful supermassive black celestial sphere, so that its gravitational forces are strong enough to maintain the orbital movement of its 56 satellite galaxy in their capture's orbit, and by hypothesis to contribute gravitationally to the orbit displacement of about half of its objects captured in the prograde direction and the other half in the retrograde direction, and among them 56 captured satellite galaxy, in addition to the fact its captured objects are at considerable distance from the center of the Milky Way. So that's enough for this video. I don't want to read too much text, so this way it's not too heavy to explain and keep energy to add more explanation when it's necessary. So of course the mass of our supermassive black celestial sphere could not be at only 4.5 million solar mass, but much more with a mass which is 580 billion masses. So and with the biggest mass, it's give much more chance to work than with the only smaller mass, because otherwise the black or dark energy does not exist, and the black or dark matter does not exist too. So the only thing that exists in the universe, it's only gravitational force and nothing else to make them moving around another object. So that's enough for this video, and see you to another video. Thank you and have a nice day.